Hello, everyone. It's another learning day. May the blessings of the clear mind and eagerness to learn be yours. Again, this is your teacher Marlene, and allow me to add you more knowledge using today's video. The topic that we are going to tackle is about the midline theorem. Before we start on this topic, let us differentiate the postulate from a theorem. Postulate is a statement that is considered true without proof. So every time we encountered postulate, we have to accept the idea behind it. Otherwise, theorem is a proven true statement, meaning its idea is derived from a series of tests and proving before it is accepted. So what is all about the midline theorem? It is the statement that joins the midpoints of two sides of a triangle which is parallel to the third side and half as long. Let us put this into illustration and proof. Observe that we have triangle H and S. In a triangle, point O is the midpoint of the segment HN, and P is the midpoint of segment NS. And we are going to prove the segment OE is parallel to segment HS. And also, we have to prove that segment OE is 1/2 as long as segment HS. Now let us look at the formal proof of our theorem. So we have the column for the statements and the column for the reasons. So of course, we have to indicate that in triangle HNS, O is the midpoint of segment HN and E is the midpoint of segment NS that is indicated in our given. Then, in our ray OE, there is a point T that segment OE is equal to segment ET. That is by line postulate. So we can conclude that segment NE is congruent to segment ES through the definition of midpoint. We can now say that angle 2 is congruent to angle 3 because the vertical angles theorem. Then we can now say that triangle NEO is congruent to triangle SET. So observe that we have two sides and the included angle. So we're going to use the SAS postulate. Then observe that angle 1 is congruent to angle 4. Of course, those are the corresponding parts of our congruent triangles. Then, observe that our segment HN is parallel to segment ST. That is converse of alternate interior angles theorem. So segment OH is congruent to segment ON. Again, that is by definition of midpoint. So ON is congruent to our segment TS That is also corresponding parts of the congruent triangles. And then segment OH is congruent to segment TS by transitive property. So we can say that quadrilateral HOTS is a kind of parallelogram, because we can say this, that the opposite sides of the quadrilateral are congruent and parallel. Then, it is a parallelogram. Therefore, segment OE is parallel to segment HS as indicated in our theorem. That is, by definition of parallelogram. How about the other one? So at this point, we are going to prove that our segment OE is 1/2 as long as segment HS. So let us indicate that our segment OE plus the segment ET is equal to our segment OT. That is segment addition postulate. So our segment OE plus our segment OE is equal to segment OT. Substitution property. Then, since we have OE plus OE is the same as twice OE, which is equal to OT. The addition property. Then, segment HS is congruent to segment OT, because in a parallelogram, any two opposite sides are congruent. So twice our segment OE is equal to our segment HS by substitution. Therefore, we can now say that our segment OE is equal to 1/2 our segment HS. So by dividing both sides by 2. We are done in proving our midline theorem. I hope you get it. Now let us proceed to our application of theorem. Now in triangle MCG, we have points A and I are the midpoints of segment MG and GC. So using our figure, if AI is equal to 10.5 centimeters, let us find the length of MC. So using the idea of our midline theorem, we can say that AI is equal to 1/2 MC. Then, by multiplying both sides by 2, MC is equal to twice AI. And since our AI measures 10.5 by substitution, then multiply it by 2, we will get MC is equal to 21 centimeters. Now using the same illustration, if the length of CG is equal to 32 centimeters, find GI. So again, using our midpoint theorem, I is the midpoint of CG. So since I is the midpoint, then our CI is equal to GI, which is equal to 1/2 of the whole segment CG. Then, we can substitute our given CG is equal to 32 centimeters, then multiply this by 1/2 so that GI is equal to 16 centimeters. Again, using our figure, if our AG is equal to 7 centimeters and CI is equal to 8, find MG plus GC. So A is the midpoint of MG and I is the midpoint of CG as indicated. So therefore, the length of MA is equal to the length of AG. And if in our given, the length of AG is equal to 7, so MA is equal to 7. Then we can solve that our MG is equal to MA plus AG. And from the obtained value, MG is equal to 7 for the length of MA and 7 for the length of AG. And 7 plus 7 is 14. So, let us find the length of GI, which is equal to our CI, because I is the midpoint. Then since in our given, GI is equal to 8, so therefore we can say that CG is equal to GI plus CI. Substituting the value, we have GI, which is equal to 8, and also for CI, which is also 8. So 8 plus 8 is 16. So adding the two segments, we have MG plus GC as required in the problem. So adding 14 plus 16, we will obtain 30. Let us continue with this problem. If AI is represented to be 3x minus 2, and MC is represented as 9x minus 13, find segment AI and segment MC. So we can say, using our midline theorem, that the length of AI is 1/2 the length of MC. Then by substitution, AI is equal to 3x minus 2 and MC is equal to 9x minus 13. Then by multiplying both sides by 2, we will get 6x minus 4 is equal to 9x minus 13. Then combining similar terms by addition property of equality, we have 6x minus 9x, which is equal to negative 3x, and negative 13 plus 4 is negative 9. By dividing both sides by negative 3, we will get x is equal to 3. Let us continue. If the value of x is equal to 3, let us find now AI, which is represented as 3x minus 2. So by substituting the value of x, we will get 3 times 3 minus 2. And 3 times 3 is 9, minus 2 is 7. So AI is equal to 7. Now for MC, which is represented to be 9x minus 13, let us substitute the value of x, which is 3. So 9 times 3 minus 13, where 9 times 3 is 27, less 13 is 14. So MC is equal to 14. I hope you learned in our today's episode. And to end our discussion, let me give you our food for thought. No matter how correct mathematical theorem may appear to be, one ought never to be satisfied that there was something imperfect about it until It is also gives the impression of being beautiful. So this quote is given by George Bolt. Thank you so much for listening. And before we end, I want you to answer this statement. How well do you know? And try to look that the 2 points determine a line. The question is this statement a postulate or theorem? So try to put your comment, your answer in the comment box. Thank you for watching. God bless everyone.